SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering, and the topic of our today's discussion is the superheaters. In the last class we have discussed about the boiler attachments, and we have seen that superheaters are attached to the boiler for its efficient operation. You know, though superheaters are not the mandatory components, still these components are attached to the boiler essentially for the efficient performance or efficient operation of the boiler. So, these are accessories what we have discussed in the last class. So, since these accessories like superheaters, reheaters, are the components which directly affect the performance of the boiler, we need to look into this, the operation of superheaters, and that is why in today's class we shall briefly discuss about this particular component. So, we have seen that superheaters are basically, in fact we have discussed that superheaters are the high temperature heat transfer surfaces in the boiler. So, superheaters, if we try to write, superheaters, and these superheaters take dry saturated steam as the input and provide superheated steam at the outlet. Superheaters are two types which are used in the boiler, and those are convective superheater and radiant superheater. From the name itself we can understand that convective superheaters utilize the convective mode of heat transfer to take heat from the flue gas, and that heat is used to increase the temperature of the steam which is circulated. On the other hand, radiant superheaters utilize the radiative mode of heat transfer to increase the temperature of steam, essentially to provide superheated steam. So, superheaters are basically what we know till now, superheaters are basically convective superheater, and radiant superheaters. So, this is the classification which is obtained depending on the mode of heat transfer. So, this is basically obtained based on the modes of heat transfer. but we all are mechanical engineering student, electrical engineering student, chemical engineering student. So, we all have studied about fluid mechanics. What you can understand that when we talk about convective mode of heat transfer, so heat transfer is an important aspect therein. In addition to that particular aspect, the fluid mechanics also will play an important role. So, that is when we talk about convective heat transfer, so it is a kind of conduction plus advection. So, that advective transport, so fluid mechanics will play an important role. So, why not to look at the classification which would be based on the flow configuration. So, when we are talking about convective superheaters or radiant superheaters, heat transfer modes of heat transfer is the basic criteria for which we have arrived at this sub classifications. But question is, when there is flow of steam through the superheater and flue gas also will try to flow over the superheaters, that depending on the flow configuration, superheaters can be classified into again two categories. So, one is, so let us say this is A. So, that is called counter flow type and number 2 is parallel flow type. So, this classification is on the basis of flow direction. Right, whether the flue gas and the steam, these two streams are flowing in the same direction or opposite direction, depending on that particular configuration flow direction, we can classify superheaters into two sub classes. One is counter flow type, another is parallel flow type. So, this is B. So, you can understand the classification which you have listed over here under A, that is based on the modes of heat transfer, that is the fundamental one. Again B, so basically that radiant superheater, so long as the superheater type is radiant superheater, this particular sub classification, I mean the classification is not that much of that much important, but while we are talking about convective superheaters, the flow direction will play an important role, and based on the flow direction we can classify into these two sub classes, that is counter flow type and parallel flow type. So, let us now look into what is counter flow type and parallel flow type. So, now if we come to this particular case, so if we write the counter flow type, counter flow type. So, you know that you all have studied counter flow heat exchanger in your heat transfer course. So, the principle is same, basically as we have identified that the hot flue gas stream and steam, these two streams will flow in opposite to each other, in the direction opposite to each other. So, counter flow type, let us draw the schematic. So, you know that this is counter flow type. Basically, whether it is a convective superheater or radiant superheater, you know, a number of coil tubes or number of coil tubes are there in the superheater. Okay. So, you can see that so this is the steam direction and this is the flue gas. So, this is flue gas and this is steam. So, this is the superheater and the superheater, you know, in this arrangement you can understand that what is. So, you can understand the direction of steam is from right to left while the flue gas is flowing from left to right. So, these two streams are flowing in the direction opposite to each other and that is why the name counter flow is there. What is the advantage? So, advantage of this particular type of superheater is that, so you can understand this superheater is hanging from the roof of the boiler. So, if the boiler there is, I mean we have seen that a roof is there and superheaters is hanging from the roof. So, this is basically the inlet port and this is the outlet port and this is hanging from the roof of the boiler and this particular coil is placed inside this in the confined space and flue gas is allowed to pass through the confined space. So, flue gas is flowing in this direction. So, this is the flue gas direction, right. So, if you try to look at over here, so this is the flue gas direction and this is the steam direction. So, these two streams are flowing in the direction opposite to each other. Now, what is the advantage? Advantage is, see, I mean when the flue gas is first approaching this superheater, here steam temperature is very high and also the, that means if we take this particular portion and if we draw over here. So, this is basically a tube and here the flue gas is first approaching. So, this portion is first to approach the incoming hot flue gas stream. So, the outer temperature of the tube is very high, also steam is coming from the right to extreme right to that particular portion in a particular location. So, steam has already acquired some temperature. So, the flowing steam which is coming from the extreme right to that location, already that steam has acquired temperature from the flowing flue gas, but particularly when that steam is coming over here, inside temperature of steam is very high already, while the outside temperature of tube also will be very high because this is the part which is first approaching the flue gas which is having high temperature. So, flue gas when flowing from extreme left to right, it is exchanging heat and when the flue gas is reaching at the right side of this particular device, that temperature is reduced. So, if we give a name, so this is L1. So, if we give the name, say this is L1 and this is L2. So, temperature of flue gas at L1 is very high, while temperature of flue gas at L2 is less, relatively less, but steam temperature at L2 is also less relatively, but at L1 is high. So, that means this particular portion of the superheater is prone to high temperature because the steam temperature inside temperature is very high. So, this is the steam flow. So, this is steam and the flue gas. So, tube inside and outside temperature at this particular location is very high and which may cause the damage of the tube. So, this is the disadvantage. So, before coming to the advantage, let us first write the disadvantage. So, disadvantage is is that at L1 tube inside and outside temperature is very high and are much prone to damage right and prone to leakage, much prone to damage, that is material damage of course. I am writing material within bracket, and chances are there that I mean leak will be much prone to leak as well. So, this is the disadvantage of this particular arrangement, right. What is the advantage? Definitely advantage is effectiveness is more. This is quite intuitive, because we all have studied in the context of counter flow type heat exchanger, effectiveness is more. So, following the similar argument we can say even in this particular case the counter flow type superheaters are more effective than the parallel flow. So, this is the advantage, but the disadvantage is what we have already discussed. So, this particular aspect should also be taken into consideration while designing the counter flow type superheater. Next is parallel flow type. So, next is parallel flow type. So, let us draw the schematic. So, this is coils, as I told you, a number of coil tubes, and so this is the steam direction, okay, and so this is the hot flue gas. So, flue gas is flowing in this direction and steam is, so this is steam in and this is steam out. Okay. So, coils will, this is one coil I have shown in this schematic. So, this particular coil is hanging from the roof of the boiler. Now, this coil is placed inside a confined domain and flue gas is allowed to flow through that particular domain, and you can understand that just if you look at this particular portion, and again if you give name, this is L1 and this is L2, right. So, if we look at this particular portion, we can see that as if two streams are flowing in a direction parallel to each other. So, flue gas is flowing from left to right, also steam is flowing from left to right. So, these two streams are flowing in a direction parallel to each other, and that is why the name parallel flow is coming over here. Again let us look at the advantage and what are the disadvantages. So, you can quickly tell me first, if we write the disadvantage is if we try to recall following the logic we have studied in the course heat transfer, that the effectiveness of parallel flow heat exchanger is low as compared to the counter flow. So, I can straight away write that effectiveness is low as compared to that of the counterflow type. Okay. Then we need to look at the advantage or advantages. Now, if we compare counterflow vis-a-vis parallel flow, what we can see in the last one, that is in the context of counterflow, we have seen that when steam is coming from right side, extreme right to the left. So, this particular portion, I mean if we go back to the previous slide, we have seen that this particular location in which the temperature of steam inside is very high, also temperature of tube outside, temperature of tube is also very high. So, it is because of this reason that material may damage and chances are there to have leakage. But if we now consider this particular arrangement, so this is the steam inlet. So, inner temperature of the tube, so inner surface temperature of tube is not very high because steam temperature is not very high, though this particular portion is first approaching the flue gas. It is quite expected that the outside temperature of tube would be very high, but since the inner surface temperature is not that much high. So, that problem, considering the that problem which will arise because of the excessive temperature of the tube material will not be there. So, that so I can write that material damage due to high average temperature of tube is less. So, chances of having material damage due to high average temperature of tube is very less. So, this is the advantage. Okay. Now, but question is that our objective is to get superheated steam, right. So, when steam is coming at section L2, steam will be, because these two streams are flowing in the same direction, they will get time to have heat exchange, but question is when the steam is coming at section L2, that time though steam has acquired temperature in the course of flow from the flue gas stream, but since flue gas has already lost temperature. So, when flue gas is coming in a section or in sections close to L2, that time flue gas temperature is very less. So, that the temperature of steam which you will be getting at section L2 is not very high. On the other hand, if we go back to the counterflow type, so in this case steam is always getting, so when steam is coming at section L1, that is the outlet port, the steam temperature is very high. So, effectiveness is very high in this counterflow type, but that is not there in the parallel flow type. But on the other hand, in the parallel flow type, chances of having material damage due to high average temperature of tube surface is not very high. So, considering these two, so if we consider parallel flow type, we have to compromise the efficiency or effectiveness of the superheater. On the other hand, if we consider counterflow type, although we may get high effectiveness, but still chance will be there that the material may damage. So, considering these two, a special type which is neither purely parallel flow nor purely counterflow is considered. So, to attain relatively higher effectiveness, and at the same time we can eliminate the problem of having material damage, the possibility of having material damage. So, let us look into that particular configuration. So, configuration showing partly parallel flow and partly counter flow. Okay. So, let us look into that particular configuration. Just schematic depiction we can see. So, this is the confined space in which that superheater coil will be placed. If we take now the superheater coil, so maybe this is the coil, one end of the coil, schematic only. So, only to make you understand the configuration. So, let me draw the, so this is the flue gas, and so if I now try to give the arrow direction, so steam is coming in this direction, so you can understand. So, this is the L2 and this is L1. So, what we can see that this particular coil is suspended from the roof of the boiler. So, this is inlet, steam in, and that is steam out. Okay. So, what we can see, and that flue gas is flowing in this direction. Okay. So, what we can see, so this is, if we look at this particular, so if we give one demarcating line. So, this line demarcates two different flow configurations. What are those? If we look at the right side of this line, in this particular zone we can see that steam flow, the flue gas is from left to right, while steam is flowing from right to left. So, this is counter flow type. So, this is counter flow type. So, this is counter flow type, while if we look at the left side of that demarcating line, we can see that the direction of steam flow, the steam is flowing also in this direction in the upper part of the coil, and also flue gas is also flowing in this direction. So, these two streams are flowing in the same direction, that is from left to right, and this particular configuration shows similarity with the parallel flow type. So, this is neither purely counter flow nor purely parallel flow, it is a combination of these two, and the main purpose of having this type of configuration is to get the advantage of high effectiveness and at times to reduce the possibility of having high average temperature of tube material, so that the chances of having material damage can be prevented. So, this is the configuration. Okay. Next we will look at, so basically we have discussed about the classification, which is based on the modes of heat transfer, that is the fundamental classification. Then we have discussed about the classification based on the flow direction, and we have discussed 3 different cases: parallel flow, counter flow and combination of these two. Next is we will be discussing about third type, that is this classification based on the horizontal or vertical type. So, basically whether the coil that we have seen, if we go back to the previous 3 examples. So, coil is suspended from the roof of the boiler and it is placed in the confined chamber through which hot flue gas is flowing. If we go to the next one, here also coil is suspended from the roof of the boiler and placed in the confined space through which flue gas is flowing. This one, it is also the same, but little different, so that we can, we have discussed that it is having both counter flow and parallel flow type arrangements. So, even in this case the entire coil is placed inside the confined chamber and the coil is suspended from the coil is suspended from the roof of the boiler. But in all these 3 cases, you know that coil is vertical type, as if coil is suspended from the roof and placed in the confined domain, confined space, wherein the flue gas will be flowing. So, whether the coil is in horizontal plane or in the vertical plane, depending on this particular aspect, the superheaters can be classified into 2 subclasses, one is horizontal type, another is vertical type. Let me tell you once again, whether the coil is in the vertical plane or coil is in the horizontal plane, depending on this particular aspect, we can classify superheaters into 2 subclasses, one is horizontal type, that is coil or coils is or are in the horizontal plane, and vertical type. So, this is in which coil or coils is or are placed in the vertical plane. Okay. So, this is the classification. Now, till now we have discussed parallel flow type, counter flow type and combination of these two. All these are the examples of vertical type. So, coil is placed in the vertical plane. So, now let us look into horizontal. So, vertical type, basically coils are in the vertical plane and this is so this is. Now, if we go to the one example. So, let us draw the horizontal superheater. Horizontal superheaters. So, if we draw the schematic, and so this is the example of vertical superheater, you can understand. So, this is the vertical plane. So, if we write, so this is the vertical plane, so this is vertical plane. Now, whether it is steam in, say it is steam in and that is steam out. So, this is the direction. Question is, you know that any mechanical component or device after the after a long period will start malfunctioning because of several reasons. So, when steam is coming in and going out from this particular coil, so chances are there that condensate. So, we need to have some tap. So, because of this particular arrangement, the condensate which will be collected will remain there in this particular part, So, if we give name A, this is B. So, condensate at points A and B needs to be collected on a regular basis, and because of this particular arrangement it is very difficult to collect condensate, to drain out the condensate and in a normal way. So, what is needed? We should have these taps. So, these are called tap. Collected and which required multiple taps are required for drainage of condensate. So, this condensate should be collected on regular basis to have proper functioning of the superheater. If we need to collect condensate on regular basis, it is because of this particular arrangement it is not so easy to take it out, but since we need to take it, we should have multiple taps. So, this is the disadvantage of this particular type. What is the advantage? So, this is the disadvantage. So, this is vertical type. Let me write here. So, this is not the horizontal type, I should write this is vertical type. vertical superheaters, superheater coil is in vertical plane, right. So, this is the disadvantage. Advantage you also should mention that holding this superheater coil is more easy and simple. Because it is hanging from the roof of the boiler. So, this is vertical superheater. So, now let us briefly discuss about the horizontal superheater. So, horizontal superheater is horizontal superheater. So, this is very easy because let me write. So, superheater coil is in the horizontal plane. Okay. So, let us draw the schematic. Okay. And if we, so this is the horizontal plane and superheater is placed, right. And here if you have only one tap, so only one tap, so tap to collect condensate. So, this is steam in and this is steam out, right. So, this is in the horizontal plane, but it is because of this horizontal plane that we can easily take the condensate out from the superheater and only through one tap. So, only one tap is sufficient to take the condensate, but disadvantage is this so basically advantage is only one tap is required to, or I can write for the drainage of condensate. For the condensate. So, this is the advantage. Similarly, we also should know the disadvantages. Whether it, see, in case of the vertical superheaters, holding is easy because coils are suspended from the roof of the boiler roof of the boiler. But in case of a horizontal superheater, stability is less. Number one, stability is less because the entire system is in the horizontal plane, and when there is flow of steam, we need to have proper support to keep the superheater in place. So, first of all, placing the superheater is very easy in case of a vertical superheater because we can hang the superheater from the roof of the boiler, but in case of a horizontal superheater, placing the superheater is not so easy because we need to keep it in the horizontal plane. Since through this coil steam will be flowing. So, because of this flow there will be change in momentum. So, to keep that superheater in place we need to have proper support. So, stability is less and proper support is required. To keep the in place. But despite having these disadvantages, since drainage is not that much difficult in the horizontal superheater, horizontal superheaters are preferred over the vertical superheater, because in case of the vertical superheaters drainage of the condensate is really a difficult task. We need to have multiple tasks and that is also not an easy to have. So, despite having all these disadvantages, that is stability is less, we need to have proper arrangement to keep the superheater in place, but still since the drainage is not that much difficult, only one tap using only one tap we can collect condensate, horizontal superheaters are preferred over the vertical superheaters. So, to summarize today's discussion, we have discussed about the superheater classification, depicting the schematic diagram of different types of superheater. We have discussed about their advantages and disadvantages. We have seen that fundamentally superheater can be classified based on the modes of heat transfer, but depending on the flow configuration, their arrangement, we also can classify into another subcategories. And finally, we will see that superheaters, those superheaters are used to have superheated steam, but some cases depending on the load of the boiler, steam temperature at the exit of the superheater may decrease. To account that particular aspect, superheaters are sometimes connected in series, and that aspect we will discuss in the next class. So, with this I stop here today and we shall continue our discussion in the next class. Thank you.